Hello everyone, welcome to today's lecture. In this lecture, we are going to learn about non-restoring division algorithm. So both the algorithms are almost the same, but in the non-restoring algorithm, the operations is very simple because here only we are using the addition and subtraction. But in the restoring algorithm, we have to perform more operations, while in the non-restoring, it is quite easy rather than restoring. Okay, so here easy in the sense of easy to implement. Okay, now let's start. So this is the flowchart diagram of the non-restoring division algorithm. So first we'll start at the time this parameters are the same as restoring algorithm. First, n is equals to number of bits in dividend, a is equals to 0 initially, m is equals to divisor, and q is equals to dividend. Okay, after that we'll check the sign bit of a, or we can say that MSE bit of a, and if it is 0, at that time we'll perform shift left operation on AQ, and then a is equals to a minus m. So this is the same as restoring algorithm. But if the value of sign bit is equals to 1, at that time here as it is we'll perform shift left on AQ, and then here we'll not subtracting m from a, but here we'll add a plus m. After that we'll check again the sign bit of a, and if the sign bit of a is equals to 0, at that time we'll use q of 0 as 1, but if the sign bit of a is equals to 1, at that time we'll use q of 0 is equals to 0. The next step is to decrease the value of n, and if n does not equals to 0, at that time we'll again repeat this process. But if n is equals to 0, so again we'll check the sign bit of a. If it is 0, if it is 1, then we'll restore the value of a. So for that a is equals to a plus m, and if it is 0, sign bit of a is 0, at that time the quotient is in register q and the remainder is in register a, and then we'll stop the algorithm. So let's understand this algorithm with the help of an example. So here we'll again consider the same example, 11 division 3. So here 11 is the dividend, 3 is the divisor. Okay, so q is equals to 1 0 1 1 and m is equals to 0 0 0 1 1. Here a is the 5-bit number, so a is equals to 0 0 0 0 0 because initially the value of a register is 0. Okay, and same as we again calculate the value of minus m, like in the restoring algorithm. So for that we'll calculate the 2's complement of m, and we'll get the value 11101. so the value of minus m is 11101. So let's start with the initializing parameters. So here first step is to initialize the parameters. So the value of q is 1011, value of a is 00000, value of m is 00011, and value of n is equals to 4 because the number of bits in the dividend, which is a 4. So that is why the value of n is equals to 4. After that we follow the algorithm. So the algorithm says if the value of sign bit a is equals to 0 or 1, in both the case we have to perform the shift left on AQ. So we'll perform the shift left operation first. Okay, so here you can see that the sign bit of a is 0, and if the sign bit of a is 0, at that time we'll perform the shift left on AQ, and then a is equals to a minus m. So let's start to perform the shift left operation. So first is a blank space, then 1, then 1, then 0, and this 1 is shifted here, then 0 0 0 0, and this bit is discarded because this 1 bit is moved here. So this is a 5-bit number. So this is the shift left operation on AQ. M will take m as it is and n as it is. After the shift left operation, we have seen that we have to perform a is equals to a minus m. So we'll use q as it is. To perform m equals to a is equals to a plus m, we'll add the value minus m into a. So 0 0 0 0 1 plus 1 1 1 0 1. This is the value of minus m, and at the end we'll get the output 110 1 1 1 1 1 1 1 1 0, and m is 0 0 0 1 1, and n is equals to 4. Now again we have to check the sign bit of a. Here the sign bit of a is 1, and if the sign bit of a is 1, at that time we'll take q of 0 as 0. So the q of 0 is here, so we'll use q of 0 as a 0. So the q becomes 0 1 1 0. Value of a is 1 1 1 1 0. Value of m is 0 0 0 1 1. Yes, and after this we'll decrement the value of n. So the value of n is 3 here. So this is the first cycle. Now again we'll check n does not equals to 0, so we'll again repeat this process. So for that we have to check the sign bit of a. The sign bit of a is 1 here. If the sign bit of a is 1, at that time we'll perform shift left operation on aq, then a is equals to a plus m. So let's perform the shift left operation on aq. So first is the empty bit, then this 0 is shifted here, this 1 is shifted here, this 1 is shifted here, this 0 is shifted here, then 0, then 1, then 1, then 1, and this 1 is discarded. So after shifting process, the output is become 1 1 1 0 0 1 1 0 dash, m as it is, n as it is. Then we have to perform a is equals to a plus m. So q as it is, sorry, this is not 1 1 1 0 dash. So to perform a plus m, then we'll add m into the a. The value of a is 1 1 1 0 0 plus the value of m is 0 0 0 1 1. So 0 0 0 1 1, and the output is 1 1 1 1 1. So the 5 1, m as it is, n as it is. So after that we have to again check the value of sign bit of a. It is a 1. So if the value of a is 1, so we'll use q of 0 as 0. So the output is 1 1 0 0, because this is the 0th position of q. The a is become 1 1 1 1 1, m is 0 0 0 1 1, and we'll decrease the value of n 2. After that we again need to check that value of n is greater than 0, so that is why we'll again repeat the process. So for that we'll check the value of a. The first bit of value of a is 1. So if it is 1, then we'll perform the shift left operation. To the shift left operation, 0 0 1, this one is here, 1 1 1 1, this is discarded, m is as it is, and as it is. After that we have to perform a plus m. So this is 1 0 0 dash, 1 1 1 1 1, plus value of m is 0 0 0 1 1 1 1 0, triple 1 is 1 1 1 0 1 1 0 1 1 0, and this one is discarded. So the output of a plus m is become 0 0 0 1 0. Okay, and the value of m is 0 0 0 1 1. The value of n, so 2. Okay, the last step is we have to again check the value of a, which is 0. If the sign bit of a is 0, at that time we'll use q of 0 as 1. So the q of 0 is 1, so the value of q is become 1 0 0 1 0 0 0 1 0 0 0 0 1 1, and will decrease the value of n, so from 2 to 1. After that we'll again check the value of n is greater than 0. So we'll again check the sign bit of a, so which is 0. If the sign bit of a is 0, at that time we'll perform shift left and a minus m. So first we'll perform the shift left operation. So for that the first is blank, then this 1 is shifted here, the 0 is shifted here, this 0 is shifted here, this 1 is shifted here, the 0 is shifted here, then 1, then 0, then 0, and this is discarded. Value of m is 0 0 0 1 1, value of n is 1. Then we have to perform a minus m. So 0 0 0 1 dash. So for a minus m, we'll use value of a. Then we'll add minus m into this. So the value of minus m is equals to 11101. And the output is 110. Carry bit here. This is 0 plus 1 1 110 110 110, and this one is discarded. Value of m is 0 0 0 1 1, and the value of n is 1. The last step is we again check the value of a, sign bit of a. It is 0. If it is 0, then we'll use q of 0 as 1. So this is the q of 0. So, and we'll replace the value as 1. So the final q value is become 0 0 1 1. The value of a is as it is, value of m as it is, value of n. So we'll decrease the value of m after this. So n equals to 0. We'll again check if n is greater than 0 or n equals to 0. So here the n is equals to 0. So that's why we'll again check the sign bit of a. So the sign bit of a is 0, and if the sign bit of a is 0, at that time we'll directly say that the value of q stored in the value of quotient is stored onto the register q, and the value of remainder is stored onto the register a. So this is the register a. So this value is the remainder. This is the register q, and the value in it is the quotients. Now we have divided this number. So 11 divided 2, in which remainder is 2 and the quotient is 3. So let's convert this number. 8 4 2 1. 2 plus 1 is equals to 3. So quotient value is 3. It is true. And the remainder value stored into the register A. Let's convert it. So 16 8 4 2 1. So 2 plus 0 plus 2 plus 1 is equals to 2. So the remainder value is 2. That is true. Okay, so this is how we can perform the division with the help of non-restoring division algorithm. So that's it. Thank you so much.